and advertise services. I can discover things. I can search. I mean, it's kind of the Google concept at large. Now, this is not just talking the internet. I'm talking the U.S. federal government's enterprise will be set up on this. So whether I'm a Department of Commerce employee or a student at Purdue University, I'm a consumer. I can discover data from the federal government. I can propose and describe product and solutions that I have available. Okay? Very enlightened architecture. Exceptionally unstructured. And the goal of the CIOs is to just build the bus that will enable all this. And the agnostic protocols, right? So I don't know how much of this XML stuff is done. I went to school too long ago to really have an idea. When I went back to grad school, I had to learn C, right? So that'll tell you something. And I did punch, and actually went to Big Ten University, not too far north from here. I typed, and remember, look, I don't look that old. Please tell me I don't look that old. I typed cards. We had card decks that we carried around. And this was early 80s, okay? So about the time you were born, I was punching cards. So this is the structure. This is going to solve our problems. Why is any opinions on why everyone's racing to embrace this as an architecture? You're just shy. Why is this so good? What's the matter with the top-down hierarchy? Well, I imagine all of you are thinking you're just being bashful. You say, well, the reason it'll solve all your problems is because, you kind of flip it around, it's not designed to solve any problems. So there's no problem by its very nature that would be excluded from this architecture because I didn't use solving a problem as the basis for forming an architecture. It's stochastic, right? It can handle what comes at it, at least in theory. And that's where I'm going to try to get with a couple more slides. So now let's begin to talk security. Like any system, I don't build it just to secure it. Otherwise, they never would have forged the one ring in whatever that volcano was, right? And then it got out, right? There was a certain purpose for that. It had great power. It had great capability. I'd say here, performance, right? Everybody acknowledges with all these standards, and I think in a future slide I'll show you some of the standards. There's a lot of overhead that needs to go on to make a service-oriented architecture work. It's almost like a broadcasting, where I say I have a service or I say I need a product. That desire or fact needs to get propagated in a protocol that works for everybody. How do I create security in that? Right? Authentication, right? Confidentiality. All of these things. How do you know that I'm a student at Purdue University asking this as opposed to a Commerce Department employee or a Microsoft employee, right? All of these authentications and authorizations have to happen. They have to be facilitated. And they're going to happen with messages. I think I have that somewhere. So that's the XML messaging. So from a security standpoint, what happens if the message doesn't get through? Well, I don't get authenticated, right? So there'll be a service disruption. So we have to build a system that can handle the messaging built on the open standards. But at least in my mind, and we really don't, well, maybe before I conclude, has anyone seen a service-oriented architecture example? Has anyone built one of any scale? Ever even heard of one or read of one? You can say yes, you won't get shot. I just haven't found one. We're building a small pilot, and it's hard. So it's going to solve everything, but we haven't seen it yet. I have an image of this cloud of messages, even if all the protocols work. Because right now, a lot of this messaging is done because you have an account. Someone in advance decided that you were authorized to have that, where they give you an account, they monitor your account. So that work was done in advance. Now, anybody can come off the street, and all of that has to get captured somewhere. So in your schematic, I envision just this clouds of message traffic going back and forth, authenticating, authorizing, identifying. Of course, there'll be encryption. So we'll have the whole encrypting, decrypting. That might be illegible. That's usually referred to, and there's several different versions, as the technology stack. Well, what the blazes is a technology stack? These are a representation of the technologies on the open standards that we need to have working in order to pursue a service-oriented architecture. Now, the good news is the light-shaded ones, someone thinks are reasonably well addressed already. The darker ones, the jury's still out. Those are viewed as immature. So we're not there yet. But these all represent open standard protocols where there's usually a collaborative group. Industry, academia, United Nations is involved. I mean, this is being done the right way, but that's the hard way. So these all represent, here's our lower OSI layer, and then the service-oriented architecture layer is at the top. So these are the protocols. You ever anyone heard of SOAP before? So, okay, this is all about SOAP messaging. So all of this has to happen and work well. To me, this is a little bit intimidating. This is an awful high level of complexity. And I'm not convinced that we have adequately deconstructed what goes on, because if it's so hard to make it work, usually that implies it's very easy for it to not work. And in the security sense, that means to get inside the decision-making process. If I'm using SOAP message traffic to authenticate someone and the message doesn't get through, well, that's pretty simple, right? That person doesn't get authenticated. Maybe they rebroadcast. What happens if I hijack that? I mean, there's all kinds of nefarious things you can do to message traffic. How are we going to handle that? Do I have to digitally sign all the messages to cut out if I say man in the loop? You know what I'm talking about? Man in the middle, thank you. Man in the middle problem. So I have to do digital signature, right? Well, that adds the complexity. Any computational theorists in here? Big O notation. You know what's going to happen when we start having to encrypt and digitally sign everything? You realize the computational cost? Is that adequately being addressed by the architects? Somewhat rhetorical. I don't think it is. I'm not saying they can't build it. I'm just saying I think this problem is a lot harder than we're presenting it. And I'm here to try to champion you all to ask and pursue some of these questions, because they don't have the models, right? If you were to say, here is a simulator of a enterprise instantiation of a service-oriented architecture with 200 users using digital signatures and the technology stack or some subset of that we saw, and here's the performance models we get. That sounds like a small research topic. Does that sound like rocket science? I mean, I just made that up as I was standing here. That isn't that hard to articulate. But I guarantee you right now, the decision makers in industry and government don't have those results. No one's done that. Or if they've done it, it hasn't reached the level that I could find it, versus Google or some of my engagement with other universities. These are pressing design problems, but no one has really explored it. If we find out something now, it can, it's the old early discovery of a problem or a challenge really helps. Kind of like cancer. You're all young, so you don't worry about the big C. But if you find it early, it isn't as big of a deal. And in security, it's the same thing, right? If we can find out we have some complexity challenges now, then we can adjust this as we roll it out. This is the list of policy services in my notes. Behind every one of those, there's 3 or 4. Maybe you've read have you heard of Net-Centric Enterprise Services, NCES? That's DoD's view of how a service-oriented architecture will work. Certain services that are going to be provided for the consumers.